Hi, this is 1+sinx. You are now watching 1+sinx Math TV. Today, we'd like to share how to obtain the Maclaurin series of the square root of 1 plus sine x. Instead of differentiating the function and obtain the complicated function, we are going to apply the binomial theorem and first express in the form of binomial series. So what we have here is 1 plus sine x to the power of half is equal to, by comparing to the formula, a is equal to sine x, n is equal to the power of 1 over 2. So which means that we have 1 plus n 1 over 2 a sine x. And we plus n, so 1 over 2 times 1 over 2 minus 1 divided by 2 factorial, and a squared, which is sine square x, plus 1 over 2 times 1 over 2 minus 1 times 1 over 2 minus 2 divided by 3 factorial sine to the power of 3x. And we plus 1 over 2 times 1 over 2 minus 1 times 1 over 2 minus 2 times 1 over 2 minus 3 divided by 4 factorial sine to the power of 4 and so on. If let's say the question did not ask for many terms but only the term of x up to the power of 4, so basically we can stop here. And this is equal to 1 plus 1 over 2 sine x plus, we can make use of the calculator, so which means that we have fraction 1 over 2 times bracket 1 over 2, and we minus 1, the whole thing divided by 2 factorial, which is 1 times 2. So basically we can enter 2 is enough. And this is equal to negative 1 over 8. So we have sine square x. And for the next term, we don't have to re-enter everything again. We just have to enter those that extra. By compared to the previous term, we already entered 1 over 2, 1 over 2 minus 1, and 1 times 2. And next, we have extra 1 over 2 minus 2, and this is 1 times 2 times 3, which means that the extra term is 3. In other words, we just have to take answer and we times bracket 1 over 2, and we minus 2, and divided by 3, and we should obtain the correct value, which is 1 over 16, and we plus sine cube x. And for the next term also, we just have to change a little bit, refer to the previous term. So for this case, the extra term is 1 over 2 minus 3 and divided by 4. So this is simpler. So which means that we have negative 5 over 128 and sine to the power of 4x. Next is to obtain the Maclaurin series for the function sine x. We can let fx be equal to sine x. At point x is equal to 0, sine 0 is equal to 0. We can differentiate the function sine x with respect to x, and we should obtain cos x. At point x is equal to 0, cos 0 is equal to 1. Let's differentiate further. Differentiate cos x is equal to negative sine x. At point x is equal to 0, again sine 0 is equal to 0. We still have to differentiate, since what we need here is to express the function up to x to the power of 4. So we should differentiate until order 4. Differentiate sine is equal to cos, but we have negative, so we need to copy. So at point x is equal to 0, we have negative 1. Differentiate for the fourth time. Differentiate cos is negative sine, but then we have negative. So negative becomes positive. So at point x is equal to 0, we have 0. Since we already obtained the order 4, so we can stop here and express the function fx as a series. Fx is sine x. By referring to the value for 0, we can ignore. So starting from this value, we have 1, and this is first order, so divided by 1 factorial times x to the power 1. And we plus This is 0, ignore. This is -1. So we copy -1 divided by, this is third order. So 3 factorial x to the power 3. And next term we have 0 again. So basically we can stop here since what we need here is up to x to the power 4. Let's simplify. So 1 over 1 is equal to 1. So basically we have x here. And we minus 1 over 3 factorial is equal to 6. And we times x to the power 3 and so on. We can now substitute the Maclaurin series of the function sine x into this binomial expansion. So we have 1 plus sine x to the power of half is equal to 1 plus 1 over 2. Sine x is equal to x minus 1 over 6 x to the power 3 plus dot dot dot. And let's say we don't want to keep writing this plus dot dot dot, we can use approximately equal instead of exactly equal. So we can close bracket directly and we minus 1 over 8 sine squared x. So bracket x minus 1 over 6 x cubed to the power 2. And we plus 1 over 16 x minus 1 over 6 x to the power 3 to the power 3. Since this is cube, and we minus 5 over 128 sine to the power 4. So we have x minus 1 over 6x cubed, the whole thing power 4, and so on. And this is approximately equal to 1 plus 1 over 2 times x, 1 over 2x plus minus minus 1 over 2 times 1 over 6, 1 over 12, and we have x to the power 3. For the next term, we can first expand this square. So we have minus 1 over 8, and we have simply a minus b squared. So we have a squared minus 2ab plus b squared. When we take b squared, it's supposed to have x to the power 3 to the power 2, which means that we have x to the power 6, which is already out of the range. Since we need x to the power of 4 is enough. So basically, we can stop here and ignore that term. We don't have to calculate. So we add 1 over 16, also expand. When we expand, we have x to the power 3, and the next term, if we take cube, we should have x to the power 5. So also out of the range, ignore. So move to the next term, we have minus 5 over 128, and we have x to the power 4. Also, the others will definitely more than the power of 4. So basically, we can stop here. And we can now simplify. So we have approximately equal to 1 plus 1 over 2x, and we should now look for square. So which means that we should look for this term. This is only the term with square. So we have minus 1 over 8x squared. So this one done, we can take note and we move to cube. For cube, we have 1 and 2. This is x times x cubed, which means that we have x to the power 4 for this case. So we should be careful. From here, we have negative 1 over 12, and we should add 1 over 16, and the result is negative 1 over 48. And this is for the term x to the power 3. This one done, and this one done. And we should now move to the term x to the power 4. From here, we have negative, negative, positive. So which means that we should take 1 over 8 and we times 2 and times 1 over 6. And the result is equal to 1 over 24. Don't forget we have another term here, which is negative 5 over 128. Which means that we should take minus 5 over 128, and the result is equal to positive 1 over 384, x to the power 4, and so on. And hence, we're done. Okay, that's all for this video. Thanks for watching. Hope you like this. See you!